So these are
Yes.
common standards, right?
Right.
Right.
Yes, sir. So today I'm going to highlight those coding standards, and I believe you will definitely approach for the job interviews with experience. So
Yes.
because with this competition market, you cannot get or you cannot expect a job as a fresher. You have
Yeah,
to go along with the stream.
Yes.
definitely.
Follow the current. So nowadays the current market is demanding the professionals with at least 6-7 years experience or 8 years experience. Got it?
Got it.
So your preparation and the way you deliver or say something in the interview or the when you went into the when you go into the work environment, so you should expose all the things in such a way that you have such experience. Got it?
Got it.
So when you write some piece of code without following any coding standards, immediately you will be spotted, right, by your colleague programmers.
Yeah.
Yes.
So these are very important things. So I thought of highlighting these things for you. So I mean, I came out of Hibernate and I'm just highlighting this so that right from today you will keep practicing this.
Yes.
Right. So here, this is a common standard defined for developing Java-based application. And Java coding standard is set of guidelines and rules. And who are defining these guidelines and rules is Java community.
Okay.
Explain how the Java code needs to be organized and developed. Then, this is to ensure that the people across the world belonging to Java community would be able to understand and maintain the Java applications with ease. So this is the reason we go
Yes.
for coding standards. Next, so why coding standards? So code conventions will improve the readability of the software, the readability of the programs which you have written, then easy understanding. Because if you are explaining it, every variable method, what it does in commands, no need to go through the code then. Just reading the comments will give you an idea. Okay, this particular piece of code is doing this particular thing, task, right?
Right.
Easy maintenance and reduce maintenance cost also. So for these reasons, we go for Java coding standards. And in Java program, the organization of the program, if you see here, top level it would be comments. So it talks about who is the author, when was it written, what is the version of your program, got it? Got
Got
documentation
it.
section. Then package name in our Java, import statements, class name, member variables, constructors, public methods, private methods, and if there are any inner classes, those inner classes. You can see here, import statements followed by class name. Inside the class, we write a member variable declaration and we have to write constructors post that variable declarations. Got it?
Yeah.
If you observe, my piece of code always will follow these things. So there will be variables, then I write a constructor. So you need to follow these standards. Okay?
Yeah.
Refer as many times as possible to you, particularly this video, so that whenever you are writing some Java statement, your mind has to set that with some coding standards there. Okay?
Okay.
Public methods, private methods, and if there are any inner classes there. And you can see a file should not contain more than 2000 lines. If it is containing more than 2000 lines, you can break that and go for some other classes. Okay?
Okay.
Excuse us, Ahmed.
Yes.
I think you taught this before.
Is it so?
Yes.
Are you sure? Did we discuss this? I think.
Yeah, we discussed about this before.
Let me. Naming convention, variable declaration, all these things. Sure.
Yes. Yeah. definitely.
Okay. If it is the
Even on
case,
subnets and GSPs.
okay. Oh, we have done that. Then it's okay. All right.
Yeah.
I don't remember actually, so I thought of discussing with you. Good. You have figured it out. Better than
Mhm.
good then. All right. So
Okay.
let me take you to uh, right. Huh. Uh, Say something about that caches that are available in Hibernate. So what types of caches are available?
First level cache and second level cache.
And by default, what cache is available in Hibernate?
The
The
first
first
one
level,
Okay.
is
And what is the
for
significance of second level?
the what you said.
Significance of second level cache.
It helps to improve the performance of the code.
Okay. Still,
and
you want some more?
running the session.
Okay. Is session associated with first level cache or second level cache?
Second level cache.
Session. We have two objects. You can see here
Mm.
in the regular piece of code which we have been writing. One is session factory and the other is session. So among
Yeah.
these, I am talking about session. Is session related with first level cache or second level cache?
Second level cache.
No. Session is always associated with first level cache. Session factory is associated with the second
Yeah.
level cache.
Yeah.
Okay.
Okay.
Yeah.
Okay. Now, say something about whatever you know about this first level and second level. First level is the basic cache and it is enabled by default. Agreed. Second level,
Mm.
uh, can you name the cache which we went through by example in second level?
We went through with what is it called? H.
Yes.
Cache.
Right.
Cache.
Right.
Yeah.
So the second level caches will be provided by various vendors, right?
Yeah.
Right.
So we need to choose one among those and we need to download the jar file
Yes.
accordingly and we need to configure it, right?
Right.
Right.
Right. So caching first level, right. So you can see here there is a model class. So
Mm-hmm.
on that model class, we performed an SQL update operation. I mean to say, suppose I have a user class with a name, ID, contact number, email ID, those things. Okay.
Yes.
Okay.
I say user dot set name and give a name. Okay.
Okay.
So what happens when you set user dot set name? It means you are setting a name for the user, right?
Right.
Yeah.
So an update statement would be fired, right, to set that name.
Mm-hmm.
So you are setting a name for a particular object, right?
Right.
Right.
Whose ID may be one, for
Mm.
example. So because if you are updating an object, then obviously there should be one object, right? Particularly what object you should be able to identify, right?
Right.
So here you are performing an update on your model class, say user class, and an update SQL query would be performed by Hibernate, right?
Right.
Right.
On the same object, assume, on the same object that is user ID which has one, okay?
Mm-hmm.
You perform another update, okay?
Okay.
Yeah.
So if you look, this will not perform the second update SQL statement being running on the console. Did you try? I mean, did you try in the sense? Are you able to follow here? So I am performing on the same object, two updates. Got it?
Got it.
So two update statements has to be executed, right?
Yeah.
Right.
So, but Hibernate will execute a single update operation on it. Reason is Hibernate will intelligently reduce to minimum number of update statements to be fired on the same object. Got it?
Got it.
So you are choosing one object, maybe you who is having user ID 1. So assume Emma is the user, okay? You are updating Emma's email ID, Emma's contact number, got it?
Got it.
Got it.
Emma's address. 3 things you are updating. It means
Okay.
3 update SQL statements have to be executed, right?
Right.
But the Hibernate will intelligently fire single update operation. It identifies that the same object is being updated here. So it intelligently reduces the update statements that are to be executed. Got it?
Got it.
So this is happening because there is first level cache where the user object which you are pulling out from database into your session and performing update on that object that is available in that session. Got it?
Got it.
Got it.
So from that session, it is finally updating all the results into the database with one single update operation.
Yes.
Okay. Then second level cache. So with second level cache, which is available across multiple sessions in the application, right? And across multiple applications when different sessions in different applications are running. So with second level cache, this is also possible. One thing is across multiple sessions in same application. Got it?
Yeah.
Across multiple applications with different sessions in different applications. This is also valid. With second level cache, we can run or you can cache the data that can be available to multiple applications that are running on the server. Okay?
Okay.
Yeah.
Likewise, across clusters that are, that different applications running on different servers.
Yeah.
Okay.
So this is
Got
also
it.
possible. So what do you mean by cluster? Any idea?
Operating system, different operating system.
No. This cluster talks about databases actually.
Okay.
Let me explain you by example because in a database, if you take Oracle or MySQL, the questions when you come across a database, you can see a question from clusters. They can ask you what is a cluster. So let me explain you this because this is one of the important interview questions. Yes, I am writing in your file. Today's date is 22nd. Right. So here I say I have an employee table and I have a department table. Okay.
Yeah.
And these two tables are joined using department number, right? We have seen that examples.
Yes.
Primary key and key relationship, right?
Right.
So I am writing some SQL queries which makes use of these two tables very frequently. Okay.
Yeah.
So if you get into database, assume, so I have a database and here we can see employee table would be in one memory location, department table would be in another memory location, right?
Right.
Yeah.
So when you go there into the database and operating system concepts, so memory would be organized into table spaces, frames, pages, right?
Yeah.
Right.
So over there, employee table would be in one memory block, department table would be in another memory block. Okay.
Yeah.
Okay.
So assume employee table has 1000 rows and department table has 100 rows. Okay.
Yeah.
Now you are writing a select query. Your select query is making use of these two tables, and you are writing select queries very frequently on these two tables. Okay.
Yeah.
Your application. Now, whenever you fire a select statement, then the SQL engine has to get into this employee tables memory block to fetch data, and it has to go to department tables memory block and fetch the data, right?
Right.
So
Right.
disk input and output is happening over there, right? Disk IOs. So these disk IOs are actually costly. So it has to get into its memory, employee's memory location and department's memory location. So when there is a requirement where the SQL engine is continuously getting into this employee memory block and department memory block to fetch the data, why can't we create this employee and department table in one memory block? And we write SQL queries, and that SQL engine would read data from one memory block instead of these two memory blocks. It is possible through clusters.
Okay.
So these clusters are nothing but memory areas in DB. So here, first step what we will do is we create a cluster. So while creating the cluster, we will say that I am creating a cluster with some name. So some cluster name, where the common column is department number in our employee and department tables, right?
Right.
Now I created a cluster. Second, what happens? What is, I will add an index to this. And what is this index then? Any idea about index?
Hmm.
No
Yes,
idea.
no
No.
idea. Never heard of indexes?
Sure.
Yes, we did.
Um, you did, but you could not remember, recollect now, right?
Right.
Let me explain you. So these indexes are generally associated with tables, and these indexes are, so I write here indexes. So these indexes are associated with tables and they are used to speed up the query execution process. So whenever you are writing a select query, I mean to say, you are going to pull the data from the database. So there is an employee table. So there are hundreds of thousands of rows, and you are pulling the data from the employee table. When
Yes.
you have an index on the table, then your select query execution would be very faster.
Yes, definitely.
So when we go to indexes, there are various types of indexes. So types of indexes. So bitmap index, function-based index, unique index, primary key index, and so on. So your primary key is also a type of index.
Yeah.
Unique constraint is also a type of index. Okay.
Yeah.
And whenever you are using a function in your select query, you can create an index on function also. Then that index is known as function-based index. Okay.
Okay.
So bitmap index is a kind of index where you are going to create on such a column which has multiple null values.
Okay.
For example, in employee table, commission column. Few employees has commission, few employees don't have commission, right?
Yeah.
So you
Okay.
can create a bitmap index on such a column which has commissions. Okay.
Yeah.
Okay.
So those are various types of indexes. So here we can create index and we can associate that index to particular table. Once you
Okay.
associate the index with a particular table, and if you are writing a select query on that table, got it?
Got
Yeah.
it.
Then the index get activated. Simply writing an index on a table will not speed up the process. When
Yeah.
you pull the data from the table, so assume my employee table has 15 columns and your
Mm-hmm.
index would be on one or two columns which you very frequently use. For example, employee number. The
Yes.
employee number is a column where we can add index on it. Okay.
Yeah.
So you are using employee number column in your select queries frequently.
Mm.
Then when you use in your select query the employee number column, then the index associated with that particular column on that table gets activated and it speeds up the pulling of data. Okay.
Yeah.
Okay.
So indexes on tabular columns will speed up the process. So I write speed up the process of pulling the data. So I write here speed up the query execution, particularly select query.
Yeah.
Okay. Now I told index on the table will increase the performance. I
Okay.
told employee table has 15 columns. Okay.
Yeah.
Now if I add indexes on all the 15 columns, expecting very high performance from my select queries using the employee table, then you are mistaken.
Mm.
So the thing is, you need to add indexes onto your table on those columns which you regularly use,
Frequently. Yeah.
yes, frequently use. And we may not be using all the columns present in the employee table in our select queries. So we'll be using very few. So we have to choose wisely those columns from a particular table which are frequently used.
Okay.
And more number of indexes on a table will degrade the performance. Okay.
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 So this is another point. So more number of indexes. So more number of indexes will degrade the performance, lower down the performance of the query execution.
Yes.
Then I have another scenario. I told you, right, you are using select statement on that employee table very frequently. Okay.
Mm. Yes.
Suppose you are performing DML operations on the table very frequently.
Mm-hmm.
Maybe insert,
Update.
update, delete.
Delete.
If you are performing insert, update, delete operations very frequently on your employee table, and if your table is having indexes on it, then your DML queries would give lower performance.
Mm.
I'm talking about very frequent query executions. Okay.
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 Just hold on. I'm getting a call. Let me answer. Yes, I am back.
All right.
So I am talking about very frequent query executions of these DML statements. So when there are indexes on your table and you are performing DML operations on the table very frequently instead of select operations, then your DML operations would give lower performance. Okay.
Okay.
So I am coming back to clusters here. So here I created a cluster and I mentioned that department number column would be over there. Okay.
Yeah.
Department number being the common column. Now I am creating an index onto the cluster, and this type of index is known as cluster based index. Okay.
All right.
So I created an index on the cluster. Then I am creating a table. What table? Employee table now. Okay. Employee table.
Okay.
While creating the employee table, I will give my cluster name, this one. Okay.
Yeah.
Okay.
So create that employee table in this cluster. Got it?
Got
Got
it.
it.
Now fourth point. Create department table. So department table. Where to create? In this cluster. Got it?
Yeah. Got it.
Okay.
Now when you perform a join on this and you pull data from these two tables, then this cluster would be referenced by your SQL engine. Okay.
Yeah.
Yeah.
And you can see there is one cluster which has the data from employee table as well as department table.
Yes.
Got it?
Got
Got
it.
it.
So that's about index clusters and indexes. All right.
Yes.
All right.
And another point I would like to add here with the indexes. Assume you are writing a select statement, and we have indexes on the table, and your select statement will definitely give high performance. Now with the select statement, assume there are 10,000 rows in your employee table. I say 10 million. So 10 million, right? Okay.
Mm. No, another zero.
Yes. I have 10 million, 10 million, another zero, right?
Mm.
Yes. I believe 7 zero should be. Yes, right. 3, 6, 7 zeros, absolute. Yes. Now this is 10 millions. Okay.
Okay.
In my employee table, there are 10 million rows. With your select statement, if you are fetching all the 10 million rows with your select operation, then you cannot see the indexing over there. I mean, your query will not give her performance because you are fetching all the data over there. Got it?
Yeah.
Got it.
Your indexes would give high performance when you are extracting only 50% of the existing data. Got it?
Got it.
Okay.
So when you are extracting only 15% of the data with some where clauses, uh, all those things, functions, those things making use of in your SQL statements, then you can experience a good speed. If you are
Okay.
fetching all the data, then indexes also will not do anything. Okay?
Yeah.
Okay.
Right. And I came out right from here. So your applications may be running in different clusters on different servers. Okay?
Yeah.
Yeah.
So still second level cache can be configured and used. Okay?
Yeah.
Okay.
Sometimes in interviews they may ask you on these three things with your second level cache. Okay?
Yeah.
Mm.
So with the second level cache, can you work out with multiple applications? Yes or no?
Yes.
Right. And so here, whenever you are performing uh, getting the data from the database to your model class or model layer, okay?
Mm-hmm.
Yeah.
So to that particular data, whatever the changes are happened in the Java layers, I am talking about Java layer and database layer. Got it?
Got it.
Yeah.
Java layers, you are performing some changes to your model class. This model class, I mean to say object of your model class. This object
Yeah.
is nothing but a table row, right?
Yeah.
Yeah.
So now you are fetching the fetching one table record from a table. Now database will give you that record to when you fetch by performing an update on that particular row, because maybe in the Java layers someone is using the particular object, maybe MS record. They are performing some operations on Java in on MS record in Java layers, because
Yeah.
there is team of programmers, right?
Right.
So meanwhile, Do's came and she is fetching MS record for her usage. Then Hibernate will intelligently fire an update operation before giving MS record to Do's.
Oh, okay.
What update operation? The Java layers are used by some other programmers in the team, and they made changes to that MS object, and that is present in second level cache, those updates, right?
Yeah.
Right.
So by using that second level cache, I say, why I said second level cache, maybe there are 10 programmers. So each programmer is writing a code in their own session, right?
Yeah.
Okay.
All those sessions will use commonly the second level cache data, right?
Yeah.
Yes.
So MS object is being maybe used by maybe 4 or 5 programmers in four or five different sessions in that application, right? There may be a chance, right?
Yeah.
Now DOS is going to extract a mass record from database table. During that time, Hibernate will intelligently perform an update on it. Then it will give the data to DOS, MS data. Got
Yeah.
it?
Yeah.
So this is all happened with second level cache and first level cache.
Okay.
Okay. So along with
Okay.
this first level cache, second level cache, we have query cache also. So when we talk about caches, you can assume as 3 types of cache. One is first level, second level, and third is query cache. Okay.
Okay.
So what this query cache is? With our previous example, maybe last week we performed using some get method, right? Getting the object.
Yes.
So that get method will fetch one record information, because you are
Yeah.
passing get and your class name dot class comma id, right?
Yeah.
So there may be chances that you will be writing SQL queries also to pull the data, right?
Yeah.
So SQL queries would be having huge data in it. There are chances, right? With the get method, you are going to write extract only one object, right?
Yeah.
Whereas with SQL query, you can extract n number of rows from the table, right?
Yes.
So that n number of rows also should be cached in your application, right?
Yeah.
Right.
Yes. So there is a third one called query cache. Okay.
Okay.
And if you remember, for our EH cache example, there was an XML file, EH cache, EH cache XML file, a dot XML file.
Yes.
And in the dot XML file, cache open tag, cache close tag, we mentioned, right? Some default
Yeah.
cache and another cache which talks particularly about our class, right? Do you remember?
Yeah.
Mm.
Yes.
So we are, it means that that particular class is being cached in our application, right?
Yeah.
Yes.
Suppose there are more number of classes and you want to cache the other classes also, then you will be writing another cache tag over there, right?
Right.
So here we will see that with annotation. Okay. Were you able to listen to me? I
Yes,
mean,
we are
is my voice
following.
audible to you? Right, right. Okay.
Yes.
In this sample, I'm going to show you the same cache with annotation. Okay.
Okay.
And we will
Okay.
use of query cache here in the sample. Okay.
Okay.
All right. So I already developed this simple program because we have already gone through that cache, and I'll highlight the annotations that are applicable on this cache. Okay.
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 And another thing with yes, cache. Yes, you need to yes. So somewhere where is that? Yes. I came out with one sample and right. Yes, query cache I was talking. I have an user details class, nothing but user class. Okay,
Yeah.
Yeah.
has ID and name. Okay, that's
Mm-hmm.
it. No more attributes. Simple. I made it very simple. And with annotations, we can say that my model class is an entity, right? We can do that, right?
Yeah,
Right.
definitely.
Entity, right?
Yeah.
And
Mm-hmm.
yes, so let me comment this. I'll not be using this. And in our ecache.xml file, which we used with XML mappings, we wrote
Mm-hmm.
a cache for our class. Do you remember cache?
Yeah.
Yeah.
And here, whatever the model class you are going to cache, you need to say that at the rate cacheable. Okay.
Okay.
So this particular class would be cacheable. Then, okay.
Yeah.
Okay.
Simple at cacheable. So to make the model class objects cacheable, where in second level cache. Okay.
Yeah.
And with Hibernate CFG file, if you remember, EH cache provider we need to give right,
Yeah.
Yeah.
and use the second level cache. You have to mark it to true, right?
Yeah.
Yeah.
All right. Then I am back to, so in user details class, nothing. We added one annotation, that is my user details class would be cached. Okay, cacheable.
Okay.
Okay.
Now get into test client. So in my user details class, so with the test client, the regular statements, configuration, session factory, then session open, obtain transaction, then begin transaction. Got it?
Got it.
Got it.
I believe you have executed that query examples also. So on session, create query and you can give a select query. Okay.
Yeah, we
Okay.
did.
So from user details model class, so I am keeping this example very simple. I gave my user ID equals to 1. Okay. One record it will be fetching, right?
Yeah.
Right.
And you can say I got a query here, right?
Yeah.
Mm-hmm.
And from this query I can list and get all the records from that SQL query execution, right?
Yeah.
Right.
So I get all the users, right? List of user details, right?
Yes.
And all these two things I am performing in one session. Okay.
Yeah.
Mm-hmm.
Now I closed that session. Okay.
Mm-hmm.
I opened a new session, session 2. Okay.
Mm-hmm.
Okay.
I created second transaction. I mean to say one transaction in second session. Okay.
Mm-hmm.
Mm-hmm.
And session 2 dot create query, I am writing the same SQL query here also,
Okay.
and I got the query 2, and I can get the list of records from that by query 2 dot list, right?
Right.
Mm-hmm.
Now I am executing this. Okay. Nothing
Okay.
but I have two sessions. In one session I am obtaining. I have written a query. I have written a query to fetch user ID once data. Okay.
Yes.
Same thing I am doing in second session also. Okay.
Mm-hmm.
Now I'll execute this application and look for how many SQL statements are being fired here. Select statement.
2.
2. So one is from session 1 and the other is from session 2, right?
Right.
Yes.
So if you are configuring the second level cache, finally how many statements would be executed? 1 or 2?
One statement.
So even though there are 2 times the query that is from user details class 1, so record is being fetched
Yeah.
in 2 sessions. So from first session, whatever the data is fetched is stored in cache, right?
Yeah.
Yeah.
And the second session is going to look into that cache. If the object is existing there, use that. Got it?
Yeah. Got it.
So don't need to write a second select statement then if we configure that second level cache, right?
Yeah.
Right.
All right, all right. Now, uh, yes, yes. In my Hibernate CFG, I mentioned EH cache provider, okay, and
Yeah.
I mentioned second level cache to true, okay.
Yeah.
Yeah.
Now I go to my Hibernate test slide, and in user details class also I mentioned that my user model class is cacheable, right?
Yeah.
Yes.
Now in my test slide, you can see here there is a statement that is a method on this query set cacheable to true. You can see here there is a method.
Yeah.
So I am executing this statement. Okay, set cacheable to true. Okay,
Okay.
Okay.
set cacheable will have a boolean value, and I want this query to be cacheable. Got it? I
Got it.
mean
Yeah.
the results given by this query are to be cached. Got it?
Got it.
Yes.
And now this query gets cached, and I'm executing. So let me do this in first session. First session. Yes. I uncommented in first session. Okay.
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 Second session it is commented. I'll talk about that comment later on. Okay. In
Yeah.
second session, only query statement, then query list. That's it. Okay.
Yeah.
Okay.
In my first session, I am marking that my query is to be cacheable now. Okay.
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 Now, in my second session, I have written a query and I am listing out data from the query. That's it. Only 2 statements. Got it?
Got it.
Got it.
Now, from my session 1, the data that is given by this query would be cached, right?
Yeah.
Right.
Now I am executing this. Observe carefully.
Okay.
If you observe over there, still 2 select statements are being executed.
Mm.
Reason is this data is being pulled from the table and it is cached, right?
Mm.
And here session 2 data. So here this also we need to mark it as cache. It means
Okay.
this data you need to fetch from cache. Okay, got it?
Got it.
That.
So then my query 2 is nothing but same select statement, right? From user details user table where user ID equals to 1. Same select query, right?
Yeah.
Yeah.
So we need to mark this query 2 also set as cacheable. Okay. I marked
Yeah.
it and now I am executing. Okay.
Yes.
So
Okay.
here what is happening is I am re-executing this. Observe. If you observe, still there are two select statements being executed.
Mm-hmm.
Thing is, so what do you mean by select statement execution here with our what is that query dot list? Actually, this statement is resulting into the select query, right? Query dot
Yeah.
list.
Yes.
So what is happening is, even though you marked it the first query as cacheable, second query also cacheable, still two statements are getting executed, two select statements are being executed. The reason is, go to config file. In this config file, there is a property called cache.useQueryCache. Got it?
Yeah.
This useQueryCache, you need to mark it as true. Currently, I commented it. I
Yeah.
deliberately commented it. Okay? I am
Yeah.
uncommenting it now. Okay?
Okay.
So simply mentioning the second level cache to true and mentioning your cache provider and working out with your queries will not result as per expectation. You need to mention, you need to tell Hibernate that use query cache with this EH cache provider. Got it?
Got it.
Now I go to my test client, re-execute this. Yes, the thing is with my user details annotation, I need to mention the strategy of obtaining the data, okay,
Yeah.
of my second level. So this one. So cacheable, and here usage cache concurrency strategy. You need to write this. Write this.
Okay.
Okay. Now I am going to re-execute this. Observe there. Only one select statement is being executed.
Yeah.
So what is
Excuse me,
happening
sir.
is, yes.
What the use of that strategy? How?
So here strategy is,
Mm.
so right, right. Here the cache, so which has data, use that cache for read-only purpose, for modifying purpose. Got it?
Got it.
Got it.
So
Okay.
just I'm marking it as read-only. So if you say here, so here you can see the concurrency strategies are none, non-strict read-write, and read-only, read-write, transactional. There are various strategies. Okay,
Okay.
Okay.
I am talking about the strategies here. So I have an explanation here. I will highlight it. So we need to configure the cache as one of the options, that is cache concurrency strategy. So
Okay.
read-only is the basic and simplest level. Assumes that data is read-only, okay, not write, not modifiable, okay,
Mm.
and it is generally used only for fetching, okay. It does not
Yeah.
write onto the model class, and
Okay.
after writing onto the model class, it does not write it to the database also, of course. Because when the first thing is itself will not happen, that is writing onto the user model class, because it is
Okay.
read-only. So Hibernate is not going to worry whether the data is modifier or not to this model class. Okay.
Yeah.
Okay.
Then when you mention your model classes as read only, then Hibernate will perform. I told you will perform an update operation, right?
Yes.
So those update operations are need out to perform because it is read only then.
Yes. Mm-hmm.
So executing those update operations to catch up, trace out the changes occurred to your data, to your model class, not necessary, right?
Yeah.
Mm-hmm.
So all these things will not happen. So cleaning your cache, update your cache are not checked because your model classes are read only. Got it?
Got it.
Then write only. It means only modifiable. Okay. When it is write
Okay.
only, then your Hibernate has to clean the cache. It has to update the database according to the changes made to the model class in the Java layers. Got it?
Got it.
Else inconsistent data would be present in the table or present with the Java layers. Got it?
Got it.
Read write. So the application may write data onto the database if there is any updation on your model object.
Yes.
And the Hibernate is going to update that underlying table for your model object.
Yeah.
And that update operation is executed by Hibernate intelligently. Okay?
Okay.
Non-strict read write. So this does not enforce the kind of check. That is what checking in the sense, suppose some programmers are modifying your model class, then that modifications are to be definitely updated into the database. If it is not updated and one programmer is going to fetch that information, then he may get inconsistent data. Got it?
Got it.
So when you use this type of strategy, then Hibernate will not check that check, will not perform the checks. Okay? It is non-strict read write. Okay?
Yeah.
So there may be a chance you can read the data that was updated somewhere else and not reflected. So read write make sure that you don't read any dirty data. Do you understand what this dirty data is?
No.
Dirty data means one programmer has been working with a user, with MS record, assume. And that is not updated into database. And those is extracting MS record from database, and those would be having inconsistent data, right?
Yes.
Because the programmer who has modified MS information, that is not reflecting in the database.
Okay.
And those whoever is extracting MS information would be having wrong information, right?
Yeah.
Right.
That is what dirty data. Got it?
Got it.
Okay.
Transactional. So this is the strictest of all, and cache is transaction to transaction base. Okay? When it is transaction to transaction base, it is mainly used with sessions then, because every session would be having its own transaction, right?
Right.
So this particular strategy is not much useful with second level cache. Okay?
Okay.
So that's about query caching. Okay?
Yeah.
And here I commented this query cache to true, right?
Yeah.
You comment it and you make a trial with commenting this line annotation and uncommenting this line also. It means that this annotation is also needed because you need to mention the strategy, what type of data it is, right only. Second is Hibernate, you have to mention with the query cache to true because you are working with queries. Both are mandatory. If you don't mention, then 2 times the select query gets executed. For your 2 sessions who are operating with that from user table, right?
Right.
Clear?
Yeah.
Fine. Then I'm closing my session and we will have our session by tomorrow 5 a.m. the usual regular session.
Okay.
Okay.
I have taken this session, current session now, because this morning I could not catch the session time. And I don't want to waste a day without a session. So I just made myself available to you. And tomorrow we will meet with a few more things. Okay?
Okay.
Okay.
I mean, by
You.
tomorrow. For you,
Yeah.
it would be early morning, right? Or night.
Yes.
Sorry.
Night.
Night for us.
Mhm.
Fine. I'll email you this and you work out. Okay?
Okay.
Fine. I'm sorry.